Okay, I'm going to attempt to get through this review in one planning period. So feel free to rewind if you need to rehear something because I may be going a little fast. Okay, so this is a fourth degree. That's your highest exponent. And fourth is even. So I already know that my end behavior is going to be the same because this is an even degree. And because this 2 is positive, that tells me that both arrows on the left and right will go up. So the limit as x approaches positive and negative infinity of f of x is positive infinity. To find your y-intercept, you would substitute in 0 for x. So I know that for this one, when I substitute in 0 for x, you just end up with that last term at the bottom, at the end, I mean. So you don't necessarily have to do that when it's in standard form. Because we know that all of these numbers, when you multiply 0 by anything, it equals 0. So all of these are going to cancel, and I'll just be left with 45. And make sure you write that answer as an ordered pair. The domain. Domain, we cannot do range. We're going to actually disregard range. If it's an even degree, we cannot state the range. You won't be asked to give the range of an equation if it's even, unless you have a graph that you can look at. So we don't have a graph to reference, so we can only give the domain. And the domain is going to be all real numbers for every even or odd function. Okay, so let's list the possible rationals. So I need to list all my factors of 45, which would be 1, 3, 5, 9, 15, and 45. And then I also have to divide that by Q, which is 2. And the factors of 2 are 1 and 2. So to get my possibles, first I'm going to take these, 6 numbers, and divide them by 1. Well, we know dividing anything by 1 doesn't change it. So it'll be 1, 3, 5, 9, 15, and 45. Now I need to take all those numbers and divide them by 2. And because they're all odd, that means I just have 7 fractions. So that would be 1/2, 3 over 2, 5 over 2, 9 over 2, 15 over 2, and 45 over 2. Okay. So this is a fourth degree, which means I need to find 2 numbers before 2 solutions before I can factor it. So I'm looking for 4 solutions. Now I already know which ones are going to work, but you would start off doing 1. 1 doesn't work, so the next number is -1, and that will work. And I'm listing the coefficients in my equation: 2, 9, -87, -45, and 45. Okay, so this one should work. So I'm going to go through it, bring down the first number, which is 2, multiply, I get -2, add, I get 7, multiply, I get -7, add, I get -94, multiply, I get +94, add, I get +45, multiply, I get -45, add, I get 0. So my first solution is -1. I'm going to actually list that here at the bottom. I'm looking for 4 answers. And the first one I got is -1. Excuse me. So now I need to find another one. This is now going to be my new top row. So I'm going to make my L again, and then 2, 7, negative 49, negative 94, and positive 45. So we did 1 and negative 1. The next you would do would be 3, and then you would do negative 3. Both of those won't work, so the next number that will work is positive 5. Again, it's only because I've already done these. So 2 times 5 is 10. You add 5 times 5 plus 10 is 17. 17 times 5 is 85. You add, you get negative 9. You multiply that, you get negative 45. We add, we get 0. So yay, we have another solution, 5. And this represents my A, B, and C for the quadratic that I need to factor down to get my last 2 answers. So we have 2x squared plus 17x minus 9. I'm going to make my box. Two x squared goes here. Negative 9 goes here. We need 2 numbers that multiply to be a negative 18 and add to a positive 17. It's 18 and negative 1, so I have 18x and negative 1x. When I take out my GCFs, I have a 2x and a minus 1. So I'm going to go ahead and set that equal to 0 down here because I'm running out of space. When I do that, I get x equals 1/2. So that's my third solution. And then my fourth solution, I'm going to look at each column. First column, I can take out an x. Second column, a positive 9. Set that equal to 0. And my last solution is negative 9. So the solutions would be negative 1, positive 5, positive 1/2, and negative 9. All right, moving on to the second page. Question number 2, state the degree. It's 3, which is odd. But this is an odd, and it's also negative. What that negative tells me is that on the right side is going to go down. On the left side is going to do the opposite. So in behavior, on the left, the limit as x approaches negative infinity of f of x is positive because it's going up on the left. On the right, the limit as x approaches positive infinity of f of x is negative infinity. So that would be my answer to B. Now, all odd degree functions, if it's odd, all odd degrees, we can state the domain and range because I know that the arrows are going in opposite direction, which means that my range will also be all real numbers. So when it's odd, your domain and range will be all real numbers. Okay, now let's list the possible zeros. So what I'm going to do is list all of the numbers that can divide into 20. Oh, I skipped over C, sorry. When you do C for your y-intercept, you substitute your 0 in for x, and you will be left with 0, 20. Okay, possible zeros. So the numbers that go into 20 are 1, 2, 4, 5, 10, and 20. And the only number that can go into negative 1 is 1. Again, we don't include the fact that it's negative. It's just that number is 1. So that's the only number that I'm dividing these 6 numbers by is 1, which means that my possibles would be plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 5, plus and minus 10, and plus and minus 20. For question 3, we have to find all of our zeros. So the first thing I need to do is figure out my possible. And we have 20, which is the same number we ended with in question number 2. So my possibilities are plus and minus 1, 2, 4, 5, 10, and 20. So first you would test 1. 1 is not going to work. Then you would test -1, and -1 won't work either. But when you get to 2, it will work. Now keep in mind, this is a 3rd degree, and I need it to be a 2nd degree so I can factor it. So I only need to find one answer before I can factor it. So we're going to find that with the 2. So I'm going to list my coefficients, which are 1, -5, -4, and +20. Bring down the first number, multiply, add, multiply, add, multiply, add. So that's my A, B, and C. So now I can factor it. And fortunate for us, A is 1. So we don't need to make a box. We just need to find 2 numbers that multiply to be -10, but add to a -3, and that would be -5 and +2. So when you list your 3 solutions, the first solution is 2. The second solution is what I get when I set this equal to 0. If x minus 5 equals 0, then x equals 5. My third solution is what I get when I take the x plus 2 and set that equal to 0, which would be a -2. All right, question number B. All right, my possibilities are plus and minus. Numbers that can go into 12 would be 1, 2, 3, 4, 6, and 12. Now this is a 4th degree though, which means I have to find 2 in order to factor. Because a quadratic is a 2nd degree. So if I'm trying to get down to if I'm trying to go from a 4th to a 2nd, I need to find 2. All right. So let us go ahead and get started. So the first number that will work is -1. I'm going to do that in black. Okay. So the first one that's going to work is -1. So again, you should be pausing the video, working these out, and then comparing your answer. So the first answer is -1. I'm going to go ahead and do my synthetic division. Okay, so -1 is going to work. And then if you try 2, 2 won't work. -2 will work. So now this is my new top row. So I have 2 answers so far. So I have x equals. I'm looking for 4 answers. So I figured out that I have -1 and -2. And now I need to factor to find my other 2. Okay, so I'm going to take that x squared. I'm using these letters, or these numbers here. So that would be 1x squared minus 1x minus 6. A is 1. Pause the video, go ahead and factor it. X minus 3 and x plus 2. When I set the x minus 3 equal to 0, I get x equals +3. And when I set the x plus 2 equal to 0, I get -2. So notice that -2 is a double root. You really don't need to list that twice. I mean, I'm not going to mark off if you do, but there's only 3 There's there's 3 solutions, and one of them is a double. Okay, let's go back to how you find solutions when it's in standard form. First thing you need to do is write your factors. Remember, when you write your factors, you always flip the sign. So if I have a 0 at 1, that means it's x minus 1, and then squared, because the multiplicity is 2. Anytime it's an imaginary, we start off with x squared plus, and then we multiply this 3 times 3 to get 9. Okay, now you have to make a box to multiply this out, and I know you don't have a lot of space, so you may have to do it on a separate sheet. You have to take x minus 1 times x minus 1. Okay, I know how to do it without making a box, but I just want to make sure you all don't forget that. When you multiply x minus 1 times x minus 1, you get x squared minus 2x plus 1. And I'm going to multiply that by x squared plus 9. So I am going to make a box for this one. It's going to be a 3 by 2. And that would be x squared minus 2x plus 1, and then x squared plus 9. So when I fill in my 6 squares, I have x to the 4th, negative 2x cubed, positive x squared, 9x squared, negative 18x, and a positive 9. And my 2 like terms, these are my only 2 that are like terms. So the answer for question A is y equals x to the 4th minus 2x cubed. And this is a 1 plus 9, which is 10. And then negative 18x. And a plus 9. All right, I'm not going to work through question B for the sake of time. I am going to help you set up your factors though. So just remember, if you have a 0 at negative 4, that means you have y equals x plus 4 squared. Now, in order to get an I, we have to start off with an x squared plus. There's an invisible 1 in front of that I, so that would be x squared plus 1. So what you need to do is you need to multiply the x plus 4 times x plus 4, and then you need to multiply that answer by x squared plus 1. So go ahead and pause the video and do that. I'm going to write the answer that you should get. Okay, and that should be your answer for part B. Okay, so now let's revisit domain. Remember, there are 2 red lights. The 2 red lights are a square root and an x in the denominator. Question A does not have a red light, so the domain is all real numbers. Question B does. It has a quadratic. First thing you're going to do is factor. You need 2 numbers that multiply to be negative 24 and add to negative 2. And when I set those equal to 0, I get that x cannot be 6, and also x cannot be negative 4. So on the number line, that means I have to break my domain into 3 pieces. This is the first piece, this is the second piece, and this is the third piece. So my domain would be negative infinity to negative 4, union, -4 to +6, union, +6 to infinity. Question C only has, it doesn't have a quadratic, so we don't need to factor, but it does have a red light. So I'm going to take that x minus 7, set that equal to 0, and that means x cannot be 7. So when I go from negative infinity to positive infinity, it cannot be 7. So this has to be taken out. So I should put open circles here, which is going to only take my stick, all right, and it only splits it in half. So I only have 2 pieces of my domain. So the first piece of my domain is negative infinity to 7, and the second piece is positive 7 to infinity with the union in between. Okay, I am going to pause here and make a second part so that it's separated. So that's our first page. Now we're going to move on to our second page.